Problem number 3. How many distinct rectangles can be formed by tracing the lines on the grid below? So we have this kind of 5 by 3 rectangle. Alright, now obviously the length is a little longer than the height here, but so we're asked to find how many rectangles we can get out of this figure. So obviously one type of rectangle is just these one unit rectangles, okay? And we've got 5 by 3, so there would be 15 of them, okay? And then we could find rectangles that are 1 by 2, right, like that. And we could count those up as well. And you could just do really systematic casework and solve this problem. And you would end up with 90 rectangles if you did it very carefully. But I want to show you another way to do this problem, okay? Rather than doing systematic casework. Casework's good. There's nothing wrong with casework. You just have to be really systematic about it to make sure that you don't leave out anything. So, but there's another way to do these kinds of problems. When you look at this, in order to form a rectangle, you have to choose you have to choose 2 horizontal lines and 2 vertical lines, okay? And, depending on which 2 vertical and which 2 horizontal lines you choose, you'll get a different rectangle. So in this case, if I choose these 2 vertical lines and these 2 horizontal lines, I'll get this rectangle, right? If I were to choose, let me choose a different color here. If I were to choose this line and this line and this line and this line, then I'm going to get this rectangle here, right? So every distinct rectangle in this grid is going to have a different line that represents its top and bottom and left and right sides, okay? So what we can do is say, okay, we have how many horizontal lines? We've got 1, 2, 3, 4 horizontal lines. So if we choose 2 out of the 4 horizontal lines, and if we choose 2 of the 6 vertical lines, then we'll have a distinct rectangle, okay? So how many ways can we choose 4 horizontal lines from 2? Well, you'll have 4 choices for the first one, and you'll have 3 choices for the second one. But the order doesn't matter. It doesn't matter whether I choose this one first and then this one, or if I choose this one first and then this one. So we need to divide this by the number of ways that we can arrange the 2 lines, because the order doesn't matter. So we had to divide that by 2, because we have 2 lines, there's 2 things, there's 2 ways to arrange them. But in this case, the order doesn't matter. So it's just divided by 2. And that is called a combination, and it's often noted as 4 choose 2. That's this notation here. And so 4 choose 2 would just be 12 divided by 2, which is 6. Okay? So that's the first part. Alright? And then we have to choose 2 out of the 6 vertical lines. Alright? So we would have 6 choices for the first line, and then 5 for the second line. And then we have to divide by the number of ways there are to arrange the line, because this top part would be like the number of permutations of the 6 lines. And in a permutation, order matters. So choosing this line and then this line would be different from choosing this line and then this line. But we don't want that. Because those are the same. Those will define the same rectangle. So we had to divide this by 2, because every pair of lines that we choose will have you'll have 2 ways to order it. Okay, and so we want to get rid of those duplicates. All right. And okay, so we have 4 choose 2 ways of choosing the horizontal lines and 6 choose 2 ways of choosing the vertical lines. So if we multiply those times each other, we'll get the total number of ways to choose 2 vertical and 2 horizontal lines. Okay, so we said that this was 6 and this is going to be 15, and if we take 15 times 6 we get 90, okay, which is the same number you would get if you actually went through all the casework. I don't want, let's see, I've got 5 minutes on here. I mean, I could go through the casework. You know, you're going to have, you know, 1 by 1s. You're going to have 15 of those. You know, you're going to have 1 by 2s. Okay, so that would be the, you know, the rectangles that look like this, that span 2. So you'd have 1, 2, 3, 4. And then you're going to have 3 rows, so you're going to have 12 of those, okay? And 1 by 3s and 1 by 4s, and then you're going to have 1 by 5s, okay? And, you know, you can work all that out. You're going to have 9 of these, 6 of these, and 3 of these, okay? If you go vertically, you're going to have 2 by 1s, right? And you would have 10 of those, okay? You would have 3 by 1s, and you could have 5 of those, okay? Now, we are also going to have 2 by 2s. You're going to have 8 of those. You'd have, 2 by 3s. You're going to have 6 of those. Let's see, 2 by 4s, you're going to have 4 of those, and you're going to have 2 by 5s, which would be 2 of those. Okay, so you can see there's a lot of them. I still have the 3 bys, 3 by something. So you're going to have 3 by 2s. I already have the 3 by 1. 3 by 2s, you're going to have 4 of those. And 3 by 3, you're going to have 2 of those. And the 3 by 5, 3 by 4, we got to get 3 by 4. Wait a minute. I think I'm off here. 3 by 3s, you're actually going to have 3 of those. Right? Because you're going to have this one, and this one, right? Oops. Okay, all the way down here. So 3 by 4s, you're going to have 2, and 3 by 5s, you're just going to have 1 of those. And if you add all up those numbers, you'll get 90. So you can do that on your own. But so that's the casework way. But it's really handy to learn this trick. You know that when to form a rectangle, you got to choose 2 horizontal and 2 vertical lines, and then if you are good with working with combinations, you can figure it out a lot more quickly. So there you go.